on spiny weeds which cannot be reached manually. Then one more advantage is these are safe on erodible land where tillage may increase soil and water erosion. So these are the key factors. That's why we are forced to use the herbicides. So this is the just a comparison between chemical method and mechanical method. In chemical method, herbicides resistance plants may occur over a period of time because of continuous use of same herbicides or chemicals that may create herbicide resistant plants. Then next concern is environmental pollution, health hazards, residual effect on succeeding crop, and toxic effect on soil microorganisms. Then weed shift phenomenon also may occur and expensive cost of chemicals. Then mechanical methods. Mechanical method is, as I told, in recent age it is costlier. Then time and labor requirement, and some implements need skilled laborers to operate to attain the weed control method. Then fossil fuel consumption and soil compaction. So these are the concerns with the mechanical methods of weed control. So one thing we need to note in case of conventional spraying. In case of conventional spraying, this method is no doubt this is most popular method of weed control, but here more than 97 to 98% of the sprayed herbicides reach the destination other than their target objects, including non-target species, water, as well as food sources. So this is the main concern with the chemical that is herbicide spraying method, conventional spraying. So that's why we are trying to adopt different methods of weed control, that is different approaches of herbicides application. So one more thing is the decrease availability of labor over the period of time. The labor's availability is gradually decreasing. So this is the fate of the applied herbicides. So if you apply the herbicides, so there are a number of processes through which the herbicides goes into different processes. Here if you apply pesticides or any herbicides, so first that goes to crop runoff or end root. Then in case of excess water application or in rainfall, that go as a seepage loss or leaching. Then that also go as a spray drift. Some of the chemicals as well as that enter the other water sources through drainage. So these are the different ways or processes through which applied herbicides will go into different portions, that is different classes. So that's why in order to overcome such practices, one of the new method of weed herbicides application, that is herbigation. Here we are selectively applying the approved chemical, that is herbicide, into irrigation water and applying it through the irrigation system to the crop, weed or the field. Here we are selectively applying the herbicides to the targeted crop. Here we get select to 100% weed control. So if you look at the difference between conventional spraying and herbigation, what I just explained. So if you consider the energy, that is labor requirement, in conventional spraying it is more, but in case of herbigation it is less. The time requirement is more in case of conventional spraying and less in case of herbigation. So area coverage is also more in case of herbigation, because we are automatically applying herbicides to the crop through the irrigation. Then timeliness is difficult to achieve in case of conventional spraying, but it is easy to achieve in case of herbigation. Then initial investment, it is more in case of course it is more in case of herbigation. Then automation is not possible in case of conventional spraying, whereas we can get automation in more possibility of automation in herbicide. Then operator safety needs extra care in case of conventional spraying, whereas herbicide there is no extra care required for the operator safety. Then mechanical damage to the crops, there may be chances in case of conventional spraying, but in case of herbicide there is no damage. Herbicidal activity may reduce in case of conventional spraying, whereas in case of herbicide that will be improved. Okay, in any condition herbicide efficiency will not decrease, either it will be remain same or it may improve. Then herbicide loss is more in case of conventional spraying, whereas it is less, 60 to 70% saving of chemicals will be there in case of herbicide. Then yield comparatively less in case of conventional spraying. In herbicide we can get more yield because of better application of water as well as chemicals to control the weeds. Then this is the so far we discussed about the different methods of weed control and some of the improved method of weed control, advanced method that is herbicide. Here, even though after developing many improved weed management practices, still we are getting many of the important issues in case of weed management. So one of the important issue in present is that is herbicide resistance. So this herbicide resistance is getting more importance in recent days because of this is a global problem. Here, just I want to have a brief discussion with you regarding this herbicide resistance. So first of all, if you look at the herbicide resistance, by definition, herbicide resistance is the inherited ability of a plant to survive and reproduce following selection with the dose of herbicide normally that is lethal to the wild type of the plant. So this means earlier we were using some atrazine herbicides on a particular weed. Earlier we were controlling that weed. After 20 days, same atrazine we are spraying on that particular same weed, but now that weed is not getting controlled. So this is the difference between. This is the meaning of the herbicide resistance. Earlier, the same herbicide was detrimental to the weed, but nowadays it is not getting controlled. Same herbicides we are using, but the weeds is not getting controlled. So this is the meaning. Herbicide resistance is the inability of herbicides to effectively control a weed or crop species that was previously controlled by the same herbicide. In case of agriculture field definition, resistance population must survive the recommended rate of herbicides under normal field conditions. So this is the type of herbicide resistance. Here there are some few types of resistance. Our first one is single herbicide resistance. Here particular weed is resistant to only one herbicide. Here a herbicide A. So here the particular weed is resistant to herbicide A. With then next one is cross resistance. Here the weed is resistant to 2 or more herbicides of the similar families with same mode of action. Here particular weed is resistant to 2 herbicides with similar mode of action. So this is called as cross resistance. So if we take the multiple herbicide resistance, the next type is here particular weed is resistant to 2 or more herbicides with different modes of action. Here this resistance is maybe the result of 2 or more different resistance mechanisms. In case of cross resistance, weeds have a single resistance mechanism to the different herbicides of this with same modes of action. But in case of multiple resistance, here weeds are resistant to different chemicals with different modes of action. That's mainly due to different resistance mechanism. That weeds have 2 or more resistance mechanisms, so that they are resistant to the 2 or more herbicides. Here, if you look at the examples, in case of cross resistance, Polaris minor is resistant to diclopop methyl. and Clodinopa propargyl. In case of multiple resistance weed biotop that has developed tolerance to more than one herbicides brought about by different selection pressures. So the example is Illucina indica, that it has resistance to two or more herbicides of different modes of action. So if you look at the in detail, that is herbicide resistance, we need to know the mechanism of herbicide resistance. What is the mechanism? Why they are getting resistance? So different mechanisms works within the plant, that is the weeds, are compartmentalization or sequestration. The next mechanism is enhanced metabolism, then altered target site, then overexpression of the target protein. If you look at the compartmentalization or sequestration, in this mechanism, plants are capable of restricting the movement of foreign compounds. Here, foreign compounds are mainly herbicides within their cells or tissues to prevent the compounds from causing harmful effects. So here, some of the mechanisms in plants that are capable of restricting the movement of the herbicides. They are not allowing herbicides to enter inside the cells or tissues. Okay, in this case, then herbicides may be inactivated either through binding or removal from the metabolically active regions due to the cell to inactive region. So here herbicides won't get entry into the plant system. So that's why either it will be inactivated through the binding sites and it will be removed by the it will be removed from the metabolically active region. So the plants will not get affected. So through this mechanism, some of the plants will get escape. That is compartmentalization or sequestration. Then next mechanism is enhanced metabolism. Here, weed or crop or any plant with the ability to quickly degrade an herbicide can potentially inactivate it before it can reach its site of action within the plant. So this is also an interesting mechanism. Here, weeds will deactivate the herbicides before it reaches the actual site of the action. So here, if you look in the figure, so this is the plant cell. So the herbicide molecules will get deactivated before it enters into the actual site of action. So next one is altered target site. Here an herbicide has a specific site. Every herbicide will have a particular site of action. So in that site only they will enter and have specific action. Where it acts to disrupt a particular plant process or function. So in particular sites, the herbicides will enter and they have their detrimental effect to the weeds. So if the target site is somewhat altered, the herbicide no longer binds to the sites of action and is unable to exert its phytotoxic effect. So here in this mechanism, particular molecule will alter its site of action, where it will be unable to control the weeds. So here the target site is somewhat altered. The herbicide is no longer to bind the site of action and it is unable to exert its phytotoxic effect. Here if you see the diagrammatically, here particular enzyme A is responsible for amino acid action. This is the so because of that amino acids productions, weeds will continue to grow. Here if you apply the herbicides, some of the herbicides are known to inhibit the amino acid production, so that in normal conditions the herbicides will affect the amino acid production. So because of lack of amino acid production, weeds will get die. So this is the normal condition. This is the normal weeds growth, and in case of normal herbicide, if you apply herbicides, that will affect the amino acid production. So weeds will die due to lack of amino acid production. So if you look at the altered target site, enzyme A is responsible for amino acid production. Okay, but here also if you apply the herbicides, but here what will happen? The target site will be changed. Slight change in the target sites. So in case of herbicides application, if slight change in the target site, the weeds will not die. Weeds will not die. Weeds will continue to grow because here plants themselves alter the site of action. So just they will divert the point of action of the herbicides. So herbicides will not go to the amino acid production site, that go to some other site. So in that case, the normal amino acid production will be continued and weeds continue to grow. So this is the altered site of action. So this is the interest mechanism that exists in some weeds. So that's why those weeds will have the resistance to the particular herbicides. So then one more mechanism is overexpression of the target protein. If the target protein on which herbicide acts can be produced in large quantities by the plants, then the effect of the herbicides become insignificant. Here this is also most interesting point, that suppose one herbicide, for example, that is metribuzin, that killing the weeds by affecting the particular protein, but resistance weeds what will do, they will produce the same protein in higher quantity. So in that case the effect will be insignificant. So herbicide will affect that proteins, but that proteins will be produced by plants in large number. So some protein will die and some more major portion of the protein will remain available to the weeds. So that's why weeds continue to grow. If the target protein on which herbicides acts that protein can be produced in large quantities by the plants, then the effect of herbicides become insignificant. So these are some of the different mechanisms that works in the plant system, that is the weeds against herbicides. So that's why they get resistance to the different chemicals. So here we look at the examples of herbicide resistance weeds. So for example, atrazine is resistant to different weeds across the world. Those weeds are Senecio vulgaris, then Chenopodium album, Amaranthus, Petroplexa, Solanum nigrum, then paraquat herbicide that also got resistant to different weeds such as Solanum nigrum, Midens pilosa, Illucina indica, Amaranthus lividus. Then isoprotron, in Indian context, the well-known example that is Polaris minor, then Canullus urbanensis. Those two weeds get resistance against isoprotron. For 2,4-D, weeds like Docus carota, Camulina diffusa. Then for dinitroanilines, weeds like Illucina indica. Then for glyphosate, Illucina indica, Amaranthus species and Ambrosia species. Then most important herbicide resistance weed species. Across the weed, some of the weed species got resistant to different herbicides. They are in the order. First one is rigid grass. That scientific name is Lolium sedum. Then wild oat, red root pigweed, then common damp quarters, green foxtail, barnet grass, goose grass, cochia, horseweed, and smooth pigweed. So these are the most important herbicide resistant weeds. So this is regarding the herbicides resistance in crops. So just we'll have a little discussion on allelopathy in case of weed management. Friends, here let us know what is allelopathy. Allelopathy refers to the beneficial or harmful effects of one plant on another plant through the release of biochemicals known as allelochemicals from the plant parts. So allelopathy doesn't mean that it will have a detrimental effect. So allelopathy means the effect of one plant on the other plant through release of some chemicals from different parts of the plants. So allelopathy may be positive or may be negative. Okay, allelochemicals are classified as secondary plant metabolites, which are generally considered to be those compounds such as alkaloids, phenolics, flavonoids, terpenoids, and glucosinolates, which do not play a role in primary metabolic processes essential for plant survival and are produced as offshoots of primary metabolic pathways. So allelochemicals are mainly secondary metabolites which produce in the plant from the different primary metabolic pathways. So such chemicals will release from different parts of the plant, such as some chemicals will release from leaves, stems, seeds, roots, and crop residues. Even after decomposition, while decomposition of crop residues, some of the chemicals will release in the decomposition processes, though those chemicals also inhibit the growth of some other plants. So that is also called allelopathy. Then allelopathy offers potential for biocontrol, biorational weed control through the production and release of allelochemicals from leaves, flowers, seeds, stems, and roots of living or decomposing plant materials. Under appropriate conditions, allelochemicals may be released in quantities sufficient to developing weed seedlings. Allelochemicals often exhibit selectivity similar to the synthetic chemicals. So this is all the feature plants we have in case from this allelopathy mechanism. Here we can use this allelochemicals like synthetic chemicals, but there are many other issues in case of allelopathy. Please, sir. So this is the feature. There is a lot. There is a great feature is there for allelochemicals, but there are many other issues such as how to extract the allelochemicals, then how to identify the particular allelochemicals in different plants, how to use these allelochemicals to control the weeds in different weeds. So these are all some of the points to really we have to concern regarding in order to popularize the allelopathic weed control measures. So if you look at the history of allelopathy, Theophrastus long back disciple of Aristotle reported an example of the inhibitory effect of pigweed on alfalfa. So the history is long back. Many scientists and many scientists have reported the allelopathic effects of one plant over the other plant, but generally we consider the one of the man that is known for his allelopathic research, that is Hans Smolish. Hans Smolish studied the effect of ethylene on plant growth and coined the term allelopathy. So allelopathy is the Greek word allelo, and pathy means mutual and harm. So but at the time of he described allelopathy as both beneficial and harmful biochemical interaction between the organisms. This was supported by again Putman and Duke pointed out that Molish's choice of the term was technically erroneous. So he Hans Polish coined the and they defined allelopathy may be positive and negative effect both, but in general some people tell that allelopathy is mainly a negative effect. But in actual meaning, allelopathy means just effect of one plant over the other plant by releasing some of the chemicals. But generally, people understand allelopathy means that is negative effect. So this is the release of allelochemicals. Some of the allelochemicals released through volatilisation from leaves. Then some of the allelochemicals leach from the leaves by rain, fog, or dew that affects the other plants. Then from decomposition, as I told, decomposition of plant litter or release or through the transformation. Then decomposition of the root tissue, then exudation from roots, leaching from plant litter. Then that chemical goes to the transformation from microorganisms in the soil. So through different mechanisms that chemicals affects the growth of other plants. So this is the different these are the different mechanisms that works in the allelopathy. So for in order to take any allelopathic chemicals, we need to study this much practices. That's why the allelopathy study is somewhat difficult. Then this is the examples of allelochemicals. Here allelochemicals group phenolic acids. That group includes different acids, that is caffeic acid, fumaric acid, phenolic acid, synergic acid, then hydrobenzoic acid. So these plants containing allelochemicals are rice, wheat, mango, spotted knapweed. Then functions is, the main functions are increasing cell membrane permeability, affecting ion transport, then and metabolism, then disruption of cell division, malformed cellular structure, reduced respiration, then reduce photosynthetic rates, and ultimately inhibit the photosynthesis. That's why this is the mode of action. These chemicals inhibit the growth of other weeds or crops. Then next allelochemical group is, that is glucosinolates. Then plants containing these glucosinolates are Brassica, Brassicaceae family, radish, mustard, turnip, and rapeseed. Then reduced by mechanisms of function such as reduced seedling emergence, size, delayed seed germination. Then coumarin group of chemicals, the allelochemicals including species are Apiaceae, Astraceae, Fabaceae families, lettuce, wild oat. So the main mode of action is reduced seedling germination, root to seed ratio growth reduction, then interfere with photosynthesis, respiration, and nutrient uptake. The next allelochemical group is benzogenoids. That plant species contain are cereal grains, wheat, and rye that diminish plant germination and growth. Then next, these are some of the chemicals, that is halonoids and benzoquinone that found in sorghum and sunflower. Here they show different mode of actions. Here in case of sunflower, the decomposition of after decomposition of sunflower ratio, that some of the chemicals will affect the germination of the subsequent plants. So allelochemicals are very difficult to isolate. As I told, weed suppression we can get better mainly from allelopathy and some extent of physical interference. Physical interference includes impedance of light, water, nutrient by cover, crop residue, or living mulch. So these are some of the meteorological factors that affects the release of allelochemicals in a particular plants. So some of the meteorological factors which are responsible for the allelochemicals are the temperature, precipitation, and light intensity. Here if you look at the just plant mechanism, here the leaching of allelochemicals from the plant parts will definitely altered by the temperature, precipitation, and light intensity. So through that the leaching effects will be different, so that allelochemicals activity will be also different. So then dead shoots also, some of the leaching process will take place, then chemicals will reach, and some of the root exudates So soil factors such as organic matter, water, then microorganisms, pH and clay content also affects the allelopathic activity. Then dead roots and rhizomes, then leaching, then tension, transportation, transformation, then absorption, presence of soil water. These all factors in the soils will also affects the allelopathic activity of a particular chemical. So this is the donor plant. Means allelochemicals releasing plant. So this is the receiver plant. So receiver plants may get damaged may get suppressed from the chemicals of this donor plant. So this how much receiver plant will suffer, that depends on the extent and degree of activity of these allelochemicals. So in presence of soil water, this receiver plant will absorb the allelochemical from the donor plant. So by this chemical, the growth of the receiver plant will be reduced. So as I discussed, the factors affecting allelopathy: light, mineral deficiencies, water stress, temperature, age of the plant, day length, varieties, specificity, phototoxicity, crop and crop effect. So this is the mode of action of allelochemicals. There are different number of actions through which particular chemical reduce the growth of another plant. So the different mode of actions are cell division and cell elongation, then phytochrome induced growth, porphyrin synthesis, then stimulation or inhibition of certain specific enzymes, then corking and clogging of xylem elements. So this is the site of action of allelochemicals. As we told for herbicides, similarly these allelochemicals are also nothing but biocompounds chemicals. So they will also have different site of action. Molecular and at molecular and biochemical level, decreased synthesis of DNA, RNA, housekeeping protein, then increased synthesis of stress protein such as proline accumulation, that inhibition of the enzyme activity. So through these different mechanisms, the activity of receiver plant will be reduced. Then allelochemicals also affect at structural levels, alteration in cell ultrastructure or inhibition of mitosis. Then these allelochemicals also affect at physiological levels, mainly by alteration, melting in photosynthesis, then mitochondrial respiration, ion uptake, growth and development. So how allelochemicals inhibit growth? This is also same what I explained earlier. That is phytochrome interaction, photosynthesis inhibition, hydrolytic enzymes inhibition. Then through different mechanisms, the ultimate growth will be reduced. So there are some two types of allelopathy are direct allelopathy and functional allelopathy. Here direct allelopathy is here this is the donor plant, this is the acceptor plant. Here chemicals will directly received by the plants and plant growth will be reduced. This is called direct allelopathy. In case of functional allelopathy, there is somewhat indirect interference is there. This is the donor plant. This is the release of chemicals from donor plant. This will get converted by the microbials into other form that will be taken by the acceptor plants. Then this growth will be reduced. This is functional allelopathy. Here mainly interference of microorganisms will be there to activate or deactivate the functional groups in the chemicals. So this is indirect method of allelopathy. So this is direct allelopathy and functional allelopathy. So allelopathic crops, if you look at the crops, I also explained rice, that allelochemicals, phenolic acids, then weeds, inhibits or water hyacinth. So these are all the examples. So this through these crops we can have a better control to the some extent over the different weeds. So here velvet bean, the yellow chemicals involved is L-dopa. So through this chemical we can inhibit the weeds such as field poppy and creeping thistle, mainly by shoot and root growth reduction. Similarly, in case of cucumber, the yellow chemicals like benzoic and cinnamic acid, they inhibit mainly by delayed seed germination. Then in case of mustard or radish, yellow chemicals such as allyl isothiocyanates and glucosinolates inhibits weeds such as spiny thistle, pigweed, banana grass, morning glory, white carrot and wild mustard by growth inhibition through physical suppression. So the next is clover and sweet clover. The yellow chemicals are isoflavonoids and phenolics. The weeds inhibited are associated with grassy weeds through inhibition of photosynthesis. In case of oat, scopolamine and phenolic acids release that controls the weeds such as lampquarts by suppressing weeds growth. Then in case of sorghum, the yellow chemicals such as sorgoleone, cafic and chlorogenic, the weeds inhibited are Abutilon indicum and striga species mainly by growth and seed production reduction. Then in case of wheat, the chemicals such as ferulic acid, fumaric, hydroxamic acid inhibit the weeds such as Canola cervensis, Decloptium aegyptium and Avena fatua. This mainly affects the weeds by producing the general growth pattern. In continuation, some of the crops such as coffee, the yellow chemicals released, that is 1,3-trimethylxanthine. Then weeds inhibited are Amaranthus pinosis. Then type of inhibition is germination inhibition. In case of maize, increased catalase and peroxidase activity by root extract. Associated weeds, some of the important associated weeds will be controlled. Then that is also by general growth inhibition. In case of sunflower, anilonolides, then AE, helinol, AC. Then weeds inhibited are Datura, Hearth, Pursulane, then affects the uptake and growth. So here so far we are discussing different weeds having different yellow chemical, different crops having different yellow chemicals which control some of the weeds through different modes of action. We just reported these yellow chemicals, but in practical we are not exploiting this mechanism, these chemicals for the normal weed control. So there are many constraints I told for the after many researches and other things. Researchers found some of the chemicals in particular crop, they control the particular weeds through different modes of action. But so far in practically we are not exploiting this allelopathic approach of weed control. So this is the reality. Only some of the important practices we are following in case of allelopathy, such as if we grow the sunflower crops like sunflower, after sunflower crop, some of the germination of the next crop immediately if you take up the sowing up the some of the sensitive crops after sunflower, the germination percent will be reduced, mainly because of chemicals released during the decomposition of sunflower planting residues. So after some times those residues get decomposed and other processes of losses. So after that I can get good germination of the succeeding crop after sunflower. So some of the allelopathic weeds are buckwheat, then Johnson grass, horse porcelain, chenopodium, cogon grass, hairy wedge, and datura. These are all some of the secondary metabolites they release during the primary metabolism of the plant. Some of the weeds inhibited are barnyard grass, button weed, upland weeds, wild oat. Then type of inhibition is mainly seedling germination, general growth inhibition, and seedling curling. These are also some of the examples. So just I discussed regarding the constants in allelopathy. So there are many constants. Alleochemicals are short-lived in the soil. We don't know the exact time of activity in the soil. Then complicated chemical structure to analysis. There are different similarity of the chemical structure, so it is very difficult to identify. Then small amount of compounds available for bioassay. You will not get good amount of chemicals for the bioassay. Then complexity of interaction, difficult to give the concrete instructions on how to apply. Then isolation and applying from outside needs time, space, and money. Then we don't know always whether they are primary compounds or if they have been changed by the microorganisms. It is very difficult to identify the originality of the chemicals, because after releasing from plant parts in soil, that chemical will get altered due to microbial actions. So it is very difficult to identify. Then difficult to establish where and when compound is contacted in the environment by the soil medium. So it is very difficult to quantify exactly. Then autotoxicity, heterotoxicity. It is rare for single alleochemicals to exist alone under field condition in concentration large enough to have sufficient effects. So this is also one more point of concern, that is, in reality there is no single chemical will present in large quantity to have a control over the weeds. So then production and release of alleochemical transformation in the soil and uptake in the receptor plant as well as in the plant action to the compound are highly dependent on the environmental conditions. So these are the points of concern. So that's why there are many concerns in allelopathy. So from this allelopathy, so many points we have discussed, but some of the key points to be remember from this allelopathy are: combined incorporation of sorghum, sunflower, brassica species has potential to suppress the jungle rice and other grasses through physical suppression and release of alleochemicals. So these are some of the things which can be used practically. Then next one is soil incorporation of Cassia auriculata at the rate of 10 ton per hectare have better control of wetland weeds. Cassia accidentalis provides toxic effect on biochemical activities of Parthenium stroporus. Then allspice and eucalyptus provide the excellent inhibitory effect on germination and seedling growth of field dodder. Then allelopathic effect exactly depend on the concentrations of compound. Phytotoxicity of alleochemicals depends on their movement, fate, and persistence in the soil. Alleochemical production more in vegetative stage than in reproductive stage, more in aerial parts than the underground parts. So these are some of the points you need to remember. Then allelopathy is contributing to the biological solution for fertile problems in agriculture by ensuring productivity and potentiality through reduction of synthetic requirements. So there is much scope in case of allelopathy. If you get success in some of the allelopathic mechanisms and control activity, definitely will have a greater advantage in reducing the application of these chemicals. So next point I want to discuss with you is herbicide residues and residue management. This is also one of the burning issue at a global level. We are using indiscriminately. We are using different herbicides at different rate other than the recommended dose. Generally, we are using 3 to 4 times higher doses than the recommended doses. So that's why we are facing different unknown problems of the herbicide residues. That's why the topic herbicide residues and their management is getting more importance at global level. So this is also one of the discussing topic in the field of weed management. So just for refreshment, so this is the comparison of sale of agrochemicals. If you take the category wise, insecticide, as I discussed, in India the sale of insecticide is 74% from the different chemicals, whereas worldwide insecticide sale is very less compared to Indian scenario. Whereas in case of herbicide scenario, this is exactly reverse of that insecticide. Globally, India is using lesser percentage of herbicides, but other world using more and more herbicide chemicals. Globally, herbicides are the chemicals which has greater usage. Next comes insecticides. But in Indian conditions, we are more using insecticides. Then fungicides, India is using 11% of fungicides, then world is using 18%, and other chemicals India is using 1%, other the world is using 7%. So here the message we need to remember is the group of chemicals which have greater use in Indian agriculture are insecticides, whereas in case of world agriculture are herbicides. So these 2 points you need to remember from this. So just I discussed about the use of herbicides and advantages. So again, I am telling that this method saves the labor, thus enabling coverage of large area. Then timely and efficient control of weeds suited to inaccessible areas and under unfavorable conditions. Then this replaces or minimizes the delays from farm power machinery. Then this conserves soil moisture, nutrients, and it is often cost effective. Then encourages people to take up farming because of better weed control. Then increases the total farm productivity by diverting labor to the more productive work. So these are some of the advantages with herbicides usage. That's why we are using. So this is the fate I discussed. Plant uptake. Herbicides, some of the portions will go as voltage loss, then photo decomposition from light. Then some of the herbicides will be taken by the growing crop plants. That is, then some of the herbicides will go loss as absorption, desorption, then through leaching and chemical and microbial decomposition. So in this different mechanisms, physical processes such as volatilization, leaching and surface runoff. Chemical processes is photo decomposition, adsorption, desorption, chemical and plant uptake. Then biological is microbial. Here also physical losses, chemical losses and biological losses. Similarly, in case of plants also herbicides will go under different mechanisms as in the soil. So in case of plants, applied herbicides will go as a loss or that changes its form, mainly through oxidation, decarboxylation, hydrolysis, dealkalinization, then conjugation, ring cleavage. These are some of the mechanisms through which herbicides get dissipated in the plant system. Means its activity gets changed. It's may enhanced or it may reduce. So through this mechanism, the applied herbicides in the plants will get changed. So this is the relative behavior of herbicides in the plant soil. So herbicides belongs to group dinitroanilines are short to moderate residue retention in the soil, that is 10 to 90 days. Thiocarbomates have a very short to short period, that is less than 10 to 30 days. Then chloroacetamides, very short to moderate period, that is less than 10 to 90 days. Then substituted ureas, short to moderate duration, that is more than 10 to 30 days. Phenoxyethoxy groups, that is very short to short duration, less than 10 to 30 days. Then sulfonyl ureas. Sulfonyl ureas and other some of the chemicals belongs to new generation herbicides. They are short to very long duration, that is 300 to 180 days. Means they remain there in the soil for a period of 4 to 5 months. So then organic phosphorus, these chemicals are not available in the. It means they get earlier decomposition. Some of the chemicals such as glyphosate. Glyphosate residue will not be there in the soil for more than a month. Immediately after within the 10 days, that will get decomposed. So, but in case of herbicides such as sulfonyl ureas, they will be there in the soil for a month, that is 5 to 6 months. Then this is the maximum herbicide residues limit permitted in various crops. So in case of crops like groundnut, sorghum and sorghum fodder, the maximum limit of metallachlor is 0.1 ppm, 0.25 and 1 ppm. In case of linoron chemicals, the residue in case of carrot it is 1 ppm, in sorghum grain is 0.25 ppm, in case of sorghum powder it is 1 ppm, and in case of soybean it is 1 ppm, and in wheat grain it is 0.25 ppm. In case of metribuzin, the permitted residue in corn is 0.25 ppm, and in potato it is 0.6 ppm. In case of oxychloroquine, this oxychloroquine chemicals, they belongs to new generation herbicides. These chemicals generally we use in very minute quantities in a larger area, because these chemicals are highly active and higher dose of chemicals. So these are called strong chemicals. So that's why the permissible limit is 0.05 ppm. On this, if we limit the residual limits cross 0.05 ppm, that can cause damage to the human as well as animal system. So in case of pendimethalin, in case of sorghum, ground in sorghum and maize grain, the limit is 0.25 ppm in butachlor. Then similar in case of other herbicides like diuron, clozapap, butyl, and flucloraline and glyphosate. Then how to avoid the drips? So the drift means while spraying herbicides, we will get effect of herbicides on some other crops. That is mainly due to drift effect. In case of here small droplets of herbicides, here we are spraying, but because of wind and other movements, some of the minute droplets will also have effect on the adjacent crops. So to avoid that effect, we need to use proper nozzle, then proper spraying technique, then proper time of herbicides application. That's why we usually recommend to apply herbicides in the morning and evening time, where wind velocity is less. By looking at the wind velocity, we have to plan for weed herbicide spraying. Then from WHO, they classified the pesticides based on their hazards: extremely hazardous, moderately hazardous, and slightly hazardous. Some of the chemicals such as allachlor, metachlor, pendimethalin, propylene are slightly hazardous. Then acute hazard, unlikely, there's a atrazine, metribuzin, and linoron. Then some of the maximum acceptable daily intake of some herbicides. Yes, some studies also found that in reality we are taking some amount of chemicals into our body, mainly through our food system. That is from food grain production or milk and milk products and through other products. So we are intaking chemicals knowingly or unknowingly, but we don't know what quantity we are intaking. But some of the studies indicated that there is some limit up to that limit. Okay, if you take those chemicals, there will be no effect on the human body. That critical limit is, that is maximum acceptable daily intake of some herbicides is, so allachlor, that is up to 0.01 mg per kg per day. then atrazine is 0.005 ppm, then cyanazine, that is 0.002 mg per kg per day, then glyphosate is 0.1, then linuran 0.002, then metallachlor, that is 0.15, pendimethalin 0.04 mg per kg per day, then simazine 0.005, then trifluridine 0.002. Then this is the risk of carcinogenicity of chemicals. If you look at the carcinogenicity, fungicide is responsible for higher carcinogenicity percentage, that is 60%, followed by herbicides 27%. Then next is weeds or insecticides. So the insecticides have 13% carcinogenicity. Among herbicides, allelopathy only account for 98% of dietary risk. So this is the exposure risk is linked to inhibition of cholinesterase, an enzyme essential for proper functioning of nervous system. So suppose while spraying up the herbicides, if you get exposed to some of the herbicides frequently, often, definitely we may face some of the major problems in future. So that's why we recommend safety measures while applying herbicides or any chemicals. Some of the organophosphorus compounds have short biological half-life and are exerted in the urine. Then in USA, a study revealed that atrazine residues were detected in the children of farmer families in corn belt. So in corn, they are indiscriminately using herbicides because of that herbicide resistance corn varieties. So in that area, they found the atrazine residue in the children of the farmer because of that secondary intake. Some of the management of herbicide residues in the soil. Some of the management practices through which we can reduce the effect of herbicide residues in the soil, in turn that intake through the food system by the human and animals. So some of the practices are use of optimum dose of herbicides, then application of APM. Application of APM mainly this will reduce the herbicidal activity mainly by acting as a buffering. So this reduces this absorb the functional groups of herbicides, then that binds and it will get the herbicide molecule will get deactivated, or that binds to the FIM that will not available to the plants to uptake. So the application of FIM into soil always have advantages. So in this case, this will also act as a buffering material. Flowing or cultivating the land. So throwing and cultivating the land, some of the herbicide molecules get exposed to the light particles and they get photo decomposition. So from that process, some of the herbicide molecules get deactivated or the activity will get reduced. Then crop rotation. Again, this reduces mainly the crop rotation reduces the activity of that herbicides in the soil. Then use of non-phytotoxic oil. Some of the oils we can use, some of the non-phytotoxic oil can be used. Then use of activated carbon. Same activated carbon will absorb the toxic chemicals in the soil. Then use of sweeteners and antidotes. This will also work to some extent. Then leaching the soil with frequent irrigation. So this we can do, but leaching up herbicide, leaching up chemicals through frequent irrigation, that again that may lead to groundwater contamination due to leaching. So these are some of the practices through which we can reduce the herbicide residues in the soil. So friends, so far just I have discussed some of the topics, important topics in the weed management. Some of the topics again I will cover in the next lecture. But so for the help of the students for JRF and SRF and other exam preparation, just I have prepared a few question papers. So if you wish, I can also share this question paper to you through your teacher. So you can use this question papers for your exam preparation. These question papers contain the general questions from agronomy from different topics. So there are good amount of questions just that I'm showing you. So here it is not opening. So just I will share those question papers in just a minute. Are you able to see this slide?
Yes.
So these are some of the books you must go for the preparation in case of agronomy, especially for these are books for general agronomy for different topics, but for specifically weed management, so you must refer at least 2 books. That is weed management principles and practices. That is 3rd edition by U.P. Gupta. Then one more weed management book is there. So these 2 books you must refer for the weed management options. Then these are some of the books, that is principles of crop production, agronomy, and some of the important books only I have mentioned here. So please, if you refer these books, so you can have a good command on the agronomy subject, so that it will help to clear you different exams. Not only JRF, SRF, you can also have a good command on the subject, and through that you can get clear different exams in banking and other ARS and other things. So these are some of the reference books. I will share these references list, so you can please refer these books. So other than these books, some of the question papers also we have prepared. So along with answers, we have prepared some of the question papers by considering the different topics of the agronomy. Here weed management also covered, so you can also refer some of these question papers. Although these question papers may also help your preparation, so you can test your knowledge after preparation through these question papers. Then here these question papers we exactly prepared in JRF format. Similarly, in JRF, what they will ask, so in that pattern only I have prepared these question papers. So I have prepared 3 set of question papers. So I will share these question papers to your teacher, so you can refer these question papers for you after your preparation. So before preparation, you don't go for referring these question papers. After your preparation, then only you use this question paper for your knowledge testing. So if you are getting some difficulties, again you go for preparation. So before without preparation, so don't refer these question papers. Okay, so you use these question papers after preparation only. So exactly in case of JR format only, we have prepared these question papers. 3 sets I have prepared. So you please refer those 3 sets along with these references also I will give. So through that definitely you can have good command on the agronomy subject, because this agronomy subject has 10 to 15 topics. So this is somewhat broad compared to other subject what I feel. So for this you need intensive and broad preparation. So after that broad preparation, you also need to refer some of the question papers and some of the important references. Many times you'll forget some of the important books to refer. So that's why there is a need to know the important references in agronomy. So from by referring those books and other question papers and other things, definitely you can clear your agronomic examination such as SRF and ARS. So this is I wanted to discuss with you people. If you have any some of the points regarding which these are the points need to cover in the next class, and some of the points, please you can ask.
Among the participants, if anybody having any query, they can ask to the speaker. Or you can also put your question in the chat box also.
Yes, that's also okay, sir.
So I think no any questions are there. Gule, please conclude the session.
Yes, sir. Sir, we are very much thankful to you, sir, on behalf of Department of Agriculture Extension and Communication, PGI MPKV Rahuri. You have very nicely explained all things related to the topic which was allotted to you. In that, you have in briefly explained the weeds, its definition, losses due to the weeds, pesticide used in India, especially herbicide used in India, critical period of weed crop competition, nutrient removal by the weeds, principles of weed management. Then herbicide resistance, its types, allelopathy in weed management, herbicide residues and its management, fate of herbicide applied in soil and plant. Rather than that, you have also explained different exams which are conducted by the ICAR, RB. Thanks once again, sir, for giving your valuable knowledge and connecting with us. Thank you so much.
Thank you. Some of the questions asked in the chat box are, what is the meaning of fate of herbicide or mechanism of fate of herbicides in the soil as well as plant? Fate means what is the status? What is the status of herbicides after application in the soil? Means 10 gram of herbicides I applied to the soil. So what is the status of the 10 gram of applied herbicides after 6 days? So 10 gram of herbicides from the 10 gram of herbicides after 6 days of application, 1 gram of herbicides may go from phytodecomposition loss, 2 gram of herbicides that go through microbial decomposition, and 2 grams of herbicides that taken by the weeds as well as crops, and 2 grams of the herbicides may be lost through bleaching or runoff loss. So this is the meaning. Status of herbicides in the soil as well as in the plant after application and after some time. So this is the meaning of fate of herbicides. Then mechanism of fate of herbicides. Mechanisms means what are the processes which responsible for the status of herbicides in the soil after application. Means after 10 days of application, some of the factors responsible for that is photo decomposition and microbial decomposition, they decide the what is the status of the herbicides. So that is the meaning of fate of herbicides and mechanism of fate of herbicides in the soil as well as plant.
Okay, sir.
Okay, sir. Thank you, sir.
Okay, sir. Thank you so much.
Okay, sir. Thank you. Thank you.
Dr. Pawar, sir, any announcement from you, sir? Okay, sir. Thank you. Thank you.